Okay, so let's hopefully finish up chapter 18. We left off at the point where we have been talking about the red blood cells, and the last thing that we got to, of course, was we were looking at how do we do the blood typing. We have the ABO group that we tend to, that most of the society falls into, but don't forget, we have more blood types than that, all right? We talked about the positive and the negative, and really when that might be a problem, which is at the time of pregnancy. And the HDN, the hemolytic disease of the newborn, is the biggest issue in whether the positives and negatives are present. So I think this was the point we had left off. One of the things that will happen is, in the case of HDN, these antibodies and so forth, this stuff will cross the placenta. That's one of the biggest things that happens. It crosses the placenta, and then it will actually attack the cells of the fetus. So that's why they, but you know, like I said, most of the time it's just, you know, the first pregnancy is okay, second pregnancies and forward become an issue. But if you're given the ROGAM, and then they give it to you, I think, at like 28 weeks of pregnancy, something along those lines, after the baby's born again, and usually any future pregnancies are fine. So that's one of the biggest issues. So continuing with these cells that are in the blood, okay? We had the red blood cells. The other ones we got are the white blood cells, the leukocytes, leuko meaning the white. And with these cells, we associate them with our immune system. One of the things about these cells, they keep their cell parts. If you remember, red blood cells spit the parts out. With the white blood cells, they keep the nucleus. One of the things that will happen with the white blood cells, they have lots of lysosomes. Do you happen to remember what those were, what the lysosomes were? What does it mean to lyse?
Break it.
To break it, okay? That means, based upon what these cells do, okay? And it's really cool, because these get to move around in the blood. They get to migrate to our extracellular fluid in the tissues. And anything that they encounter, because of their movement and their structure that they have, they will go up to that foreign particle, okay, virus, bacteria, what, pollen, whatever the case might be. They go up to that foreign particle, and they can actually take their plasma membrane, wrap around it, and bring it into itself, bring it into the cell. And because the cell has so many lysosomes, they attack the foreign particle and eat it. And hopefully that will get rid of whatever the foreign particle was. They are the least abundant element. If you remember from the one of the first slides, when you centrifuge the blood down, the red blood cells go to the bottom, white blood cells are the middle in that buffy coat, and then of course we have our plasma at the top. We should have about 5,000 to 10,000 per microliter when they're doing a blood count. Some of them, and depending on which ones we're going to talk about, some of them will be or just have a few hours in the bloodstream. Some will do their jobs and be gotten rid of, okay, because we'll make them again. Some of them will be formed make their way around the body, and then migrate to other tissues, specifically the lymph nodes, okay? But they will actually migrate to other tissues, and that's where they'll spend the rest of their lives. So depending on which one we're talking about will determine what they're going to do, how long they're going to be around, and where they're going to go. Their structure is complex because they keep their cellular organelles. When we talked about them earlier, we classed them as being either granulocytes, meaning it looked in the very beginning when we began to see them under the scopes, it looked like the inside, those lysosomes and stuff, looked like little granules, rock granules. So they were termed granulocytes. And then we had ones that we couldn't see the granules under early scopes, but we see them now. But because of the time frame that they were discovered, they were termed agranulocytes, meaning without. But under granulocytes, our granules have a short lifespan. Neutrophils, eosinophils, basophils. The neutrophils, and we looked at the picture, right? Mm-hmm. Where we had all of them, and I pointed out the different nuclei. Okay, that's how they're actually identified. When you have a cytologist or a hematologist, whatever the case might be, who might be looking at a blood smear, the way that they're going to identify them is based upon their nuclei and how that nucleus is shaped. In the neutrophils, these are the most abundant that we're going to have pretty much all the time. Their nucleus has about 3 to 5 lobes. They actually look like little balloons that are existing. Their granules are lysosomes and antimicrobial agents. Antimicrobial. These are very aggressive antibacterial cells. So they are looking in large part for bacteria. Now, for the most part, I mean, you all know we're covered in bacteria, right? It's really cool, okay? If you ever got to like see that in action, it's like really, really cool, okay? We kill a lot of it, which is why we get sick a whole lot. But anyway, when we have a bacterial infection, sometimes what will happen when we're looking at these leukocytes, neutrophils, eosinophils, basophils, then we've got monocytes, lymphocytes, all right? A lot of times we get sick, we go to the doctor. I don't feel good. I don't feel good. So the doctor, like, well, stick your tongue out, okay, and then they look in your ear, and then look up your nose, listen to your heart, and to your chest, and be like, okay, well, let's try a little bit of an antibiotic. So they might throw you on something, send you home, okay? You go get your antibiotic, you take it, you're still not feeling good. You're like, well, why didn't that work, okay? So back to the doctor you go. Hopefully this time your doctor's going to say, let's do a CBC with a differential. That means a complete blood count with differential, meaning look at these cells that are present. Because we know they should be in a certain amount. So if they do that information comes back, they may come back and say, well, your eosinophil count is high. And they can say, pretty sure this time of year your allergies are up, so these eosinophils are, you know, they're in high production because of everything that we're getting exposed to right now. And guess what? Let's try a new allergy medicine. So they give you a new allergy medicine, tell you to do some sinus rinses, use this nose spray, and in a week you're feeling better. Didn't need that antibiotic to begin with. But, hey, that's what happens. Okay? So, neutrophils, most abundant. Eosinophils, they're relatively scant. Very abundant, however, in mucous membranes. Right now, I am pretty sure my eosinophil count's through the roof. And it's based on what I'm suffering, okay? I kind of know that's the case, okay? So, mine, allergies. And that was so funny because I was talking to a friend over the weekend, and I'm like, but I don't see anything blooming. What's blooming? And then she started pointing out everything that was blooming. And I was like, what? No, She goes, oh yeah. And I'm like, okay, well that explains it. Well, mucous membranes. These are going to be the membranes lining the openings of our body. Okay? Anything that opens to the external environment is covered in a mucous membrane. So, this particular leukocyte, it will have chemicals in it, in that cell. Look at some of the stuff it destroys. Love this. Parasites, like hookworms and tapeworms, okay? Inflammatory chemicals, i.e. pollen. Yay. Antigen, antibody complexes, allergens. It helps us with allergies, parasitic infections, collagenous diseases, diseases of the spleen, central nervous system, because of where they're found and what they can do. So a lot of times, though, hopefully we're not infected with this kind of stuff, okay? Like, for example, the hookworms, okay? I mean, hopefully we're not infected with that. Tapeworms, well, I could probably use one for a couple months, but just saying, okay? You know, but hopefully, if these are in high number, hopefully it's just maybe an allergy. The basophils, now, these are the rarest of the red blood cells. Neutrophils, for the most part, will usually be very high in number. Eosinophils, basophils, very rare. But they secrete something called histamine. Ever heard of that? What does it do to you? That's what we tend to think about, okay? The itchy nose, the itchy eyes, the watery eyes, the runny nose, that sort of thing. Well, we're going to find histamine is needed some other times. One of the things that they do, they are a vasodilator. They dilate the blood vessels so that the blood flow can increase. And this is important when we have an injured tissue. Think of a paper cut, okay? And with a paper cut, for the most part, you know, we do whatever we're doing, we get the paper cut. Most of us kind of notice it and go, and keep on going, okay? Well, there's a whole lot of other things behind the scenes that are happening. One of them is this leukocyte.